video, we're going to look at a different application of evaluating expressions using the sum and difference identities. This one provides you a different setup. It provides you with what sine of alpha is and what sine of beta is. And the expectation is that based on which quadrant we're working in, we need to be able to find cosine of alpha plus beta and the sine of alpha plus beta. Unfortunately, if these quadrant details weren't given, there would be multiple different answers for the sine of alpha and the sine of beta. Multiple different answers for these two individual situations, because we might have to, you'll notice here, if I'm using the cosine of alpha plus beta, I'm going to start with that one. The cosine of alpha plus beta is equal to, based on the identity, cosine of alpha, cosine of beta. Again, the sign changes for cosine. Sine of alpha, sine of beta. So what I need to do is I need to go ahead, I've got sine of both of those, alpha and beta. I can go ahead and evaluate those two, but I don't have cosine. What I need to do is I need to be able to find cosine of both those pieces. Anytime that they give you this situation and they ask for cosine or sine of those two angles added together, it's most appropriate for us to go ahead and build ourselves a triangle. So I'm going to build my triangle inside a unit circle, but it's got to be in quadrant 2 for this situation. So remember how we build our triangles coming out of the unit circle. There's my hypotenuse. Always drop the perpendicular back to the x-axis. There's my 90-degree angle. This would be my alpha. Knowing that my alpha is there, sine of alpha is 4/5. I'm going to go ahead and do that with this triangle. It's opposite over hypotenuse. I can solve for the missing side. The missing side is going to be 3. It's one of those special Pythagorean triples. Therefore, I know what cosine of alpha is going to be now based on that triangle. I'm going to go ahead and draw the next one as well. The next one's supposed to be in quadrant 1. Again, if I wasn't given this information, technically I could have this piece right here in quadrant 2, or sorry, in quadrant 1. So 3 isn't actually the value here, it's -3, given that it's a negative x and a positive y. So in quadrant 1, when I draw this one, again, there's my 90-degree angle, there's my beta. I'm looking at sine as 1/2, so 1, 2. And this right here is going to be that value of radical 3 when we go to solve for it. Keep in mind that this could have been over here and then could be negative. It could have been in the 3rd or the 4th quadrant, depending on how they gave us these values, with them being possibly negative or positive. So after I've built those other two triangles, again, if it might help, by all means, write out cosine of alpha is equal to, again, -3/5. Down here, cosine of beta is going to be equal to a radical 3/2. And by knowing those two values, I can then evaluate the cosine of alpha plus beta with the information that I now have. Cosine of beta is going to be the radical 3/2. All I'm doing is I'm substituting what cosine of alpha is, what cosine of beta is, what sine of alpha is 4/5, and what sine of beta is 1/2. It's important to understand that we're substituting in for this entire expression, not just the angular piece, not just the trig function, but that entire sine of beta is being replaced with 1/2, because that's what it's equivalent to. And that goes true for all those details. So what we're going to have is -3 radical, that makes sure that looks like a 3, -3 radical 3 divided by 10 minus 4/10. So I'm just going to go ahead and leave that all like that, and that's what the cosine of alpha plus beta is. I'm going to go ahead and now do my sine of alpha plus beta, because that was the next piece they asked for. And remembering that the sine has the alternating trig function, so it's sine of alpha, cosine of beta, and the sine stays the same, so plus now, and it's going to be cosine of alpha, sine of beta. So the signs stay the same in the sine identities, the cosines, the signs alternate. In this sine case, the trig functions alternate, and in this case, the trig functions don't alternate. So sine of alpha, one more time, back up here is 4/5, so I'm going to replace that appropriately. Cosine of beta is over here, that radical 3/2. Plus cosine of alpha is going to be this -3/5. And then my sine of beta is that 1/2. Once I have that situation, I can simplify it, giving me 4 radical 3 minus 3 all over 10. And again, there's no way to simplify this, because if I could, the 10 would be able to divide this 4 here, sure, but it can't divide the 3. So distributing that division doesn't really make mathematical sense. That's how you deal with evaluating trig expressions when given some of the information. Don't forget that all this information, if given, can still be built into some form of a triangle that will allow us to evaluate individual trigonometric expressions in the overall identity that we're working